oxy fuel welding, when they see it, is that, oh, well, you're just melting the metal apart, right? That's not actually what you're doing. If that is what you were doing, it would be considered strictly a thermal process. However, it's actually just as much or more a chemical process as it is a thermal process. The reason for that, remember how we talked about what happens when steel is exposed to oxygen? What do we say it does?
Oxidate.
Okay. And what did we say happens when it's exposed to oxygen at a really high temperature? That oxidation happens faster, right? So what you're actually doing with oxy fuel cutting is you're heating up the steel to a really high temperature, near molten or near molten, blasting it with a whole bunch of oxygen, and that's actually oxidizing the area of the cut and then blowing away those oxidized pieces. Does that make sense? That's why along the edge of the cut you get what that slag or that dross along the edges. That's oxidized material left behind. Make sense?
Braze welding are thermal processes where no base metal is melted. Metal is joined by first heating it to a suitable temperature. Then a filler metal is melted and distributed between the closely fitted surfaces to bond them together. Filler metals for brazing become liquid at temperatures above 840 degrees Fahrenheit, while filler metals used for soldering become liquid at temperatures below 840 degrees Fahrenheit.
Okay, so brazing and braze welding, right? Important things to remember is that you're never melting the metal, okay? So with oxy fuel welding, the two pieces of metal are melting together. Braze or braze welding, they're not. What braze welding does is it's using a filler metal that's compatible to bond the two pieces of material together, all right? But you're never actually melting the base metal. The only difference between brazing and soldering is the temperature at which it's done at, right? So whether you're brazing or soldering,
It's the same temperature.
one's done above 840 degrees, the other is 840 degrees and below. Okay?
The filler metal flows into the joint due to capillary action. Oxyacetylene braze welding resembles fusion welding, except the base metal is not melted. Like brazing, the filler metal has a melting point well below that of the base metal. However, it does not utilize capillary action. The filler is distributed onto the material, and when it solidifies, the filler metal forms a bond with the base metal.
With oxyacetylene welding.
So what's different between braze welding and brazing or soldering is that brazing and soldering rely on something called capillary action. Okay? Capillary action is the ability of a liquid to flow in between two solids, right? So the way it works is, if you're brazing or soldering two pipes together, one pipe slips inside the other. The only way for capillary action to effectively work is if it's a very tight clearance between those two pieces of material, right? You heat up your base metal and you apply your brazing or your soldering rod. When it touches the material is going to melt the filler metal, and capillary action is going to draw the material up the joint, okay? Once it solidifies, it bonds the joint together, right? The strength of a brazed or a soldered joint relies on the surface area that actually gets bonded, okay? So if you have two pieces of pipe that you slide together, When you slide one pipe inside of the other, the part of the pipe that you slide into is called the socket, right? So if you have a 1-inch deep socket that you slide into, right, there's actually a formula that you can use to calculate what the strength of that joint would be based on having full coverage of filler metal across that whole 1-inch socket. Does that make sense? Where welds, the strength of the joint comes from the cross-sectional area of the weld itself. Right?
Cutting. The oxygen supply is often in the form of a cylinder containing compressed oxygen. High-volume users may pipe the oxygen directly into the workplace from tanks or tank trailers located outside the building.
Oxygen is obtained from the air through a liquefaction process. By compressing and cooling to a very low temperature, the air becomes liquid. Air is mainly oxygen and nitrogen, which, as liquids, boil at different temperatures. Since nitrogen boils off at a lower temperature, it leaves the oxygen to be transferred to tanks for transporting.
Oxygen is stored in cylinders at very high pressures, up to 2,200 pounds per square inch. Because of these high pressures, oxygen cylinders must be treated very carefully and inspected periodically. Oxygen cylinders are made from steel, are held to rigid specifications, and are built and filled under strict federal regulations. The most common oxygen cylinders hold about 244 cubic feet of oxygen and are filled to a pressure of about 2,200 psi. They measure roughly 60 inches high with the removable metal safety cap installed and are approximately 9 inches in diameter. Cylinders must be secured in the upright position, and the removable safety cap must always be installed anytime a cylinder is being stored or transported, even if empty.
The oxygen cylinder, which is designed to handle highly compressed gas safely, has a bronze double seating valve attached to the top of the tank. When the valve is fully open, the valve is designed to seal off any possible leak from around the valve stem. The threads on the nozzle of the valve should always be protected from damage. A bursting disc and safety fuse plug are included in the valve design to safely release pressure should the cylinder be exposed to extreme heat or pressure.
Acetylene is supplied in cylinders at a much lower pressure for safety reasons. Acetylene by itself cannot be safely used at pressures above 15 pounds per square inch.
That's important.
Rewind again?
1,500?
No, 15 psi.
15.
Yes. So whenever you're running an acetylene rig, whether it's for cutting, welding, brazing, braze welding, soldering, preheating, whatever it is that you're doing, under no circumstance should you ever be running over 15 psi. 1.5.
How you spell celery?
ACETYLENE.
Hey, Andrew,
Sir,
when you set the acetylene, when you cut steel, would you, I don't know if I remember, would it be eight or more pressure on it?
okay, so we're gonna get into this a little later, but I'll answer you now anyway.
I think I remember that.
When you're, whether you're cutting, welding, or brazing, right? I told you that there's different types of tips, but there's also different size tips, okay? So depending on what type and what size tip you're using, that's what determines where you set your oxygen and your acetylene flow, okay? Now, the way you determine what size tip to use is based on the material and the thickness that you're working with, okay? And that chart over there right above Ben's head goes over how to set your flame, what your oxygen and acetylene pressure should be for whatever thickness and whatever size tip you're using. Right? And you guys are also going to get some handbooks at some point that are going to have those charts as well. And while this is paused, we might as well go over this as well. This is the inside of an acetylene cylinder. If this was an oxygen cylinder, it would just be completely hollow, right? But acetylene is a very volatile gas. So it's not something that you want to just have in a cylinder bouncing around. So they pack these cylinders with a porous material, whether it's balsa wood or any type of packing that prevents the acetylene inside from just rolling around, okay? When you fill an acetylene cylinder, it's filled with acetone. So in order to prevent the gas from having any type of unwanted eruption, you have acetone and this porous material in the cylinder just to help stabilize it. Now, because of that, if you try to flow an acetylene cylinder faster than the acetylene will rise out of the acetone, you'll actually start pulling the acetone out of the acetylene cylinder with the gas. And that'll cause your torch to act erratic. Okay? It'll spit and pop.
It is stored in tanks at 250 psi. It is dissolved in acetone, which is stored in a porous material made from pumice, balsa wood, or other material.
The acetylene cylinder must also be treated carefully and inspected at intervals. Both oxygen and acetylene can be very hazardous if their cylinders are damaged or used improperly. Although the pressures used for the process are relatively low, the supplies themselves are quite high in pressure, and regulators must be used to reduce pressures to safe working level. The pressure gauges and regulators for oxygen and acetylene are similar in that they perform the same function. The gauges indicate the tank pressure and the working pressure, which is the pressure needed for a particular tip size. The regulators are made up of needle valves, springs, diaphragms, and gauges. Some reduce the pressure in one stage with one diaphragm and are the type recommended for manifold systems. These are referred to as single-stage regulators.
Other regulators do a partial pressure reduction in 2 stages with 2 diaphragms. This 2-stage regulator is the type recommended for use with cylinder supply systems. The regulators for oxygen and acetylene are different and cannot be interchanged. Historically, the oxygen connections had right-handed threads, and the acetylene and other fuel gases have left-handed threads.
The hoses used for this process are specially designed to be used with oxy-fuel systems and are color-coded to ensure proper use. Typically, the oxygen hose is green with right-handed thread fittings. The acetylene hose is red with left-hand thread fittings. The acetylene fittings may also have an identifying notch referred to as an annular groove, which designates a left-handed thread. For most applications.
Okay, so just to run through all this stuff again. Safeties that are built into the oxygen acetylene setup. Somebody give me one of them.
Color code hoses,
Okay, what are the colors?
green for oxygen, red for acetylene.
Right. Okay, what else do they do?
Regulators,
Okay, what about the regulators?
good time, proper, good time, what is stored at.
Manifold regulators.
Say that again?
Manifold regulators, like
Right. So there's regulators on there, but what stops you from mixing up the oxygen regulator and the acetylene regulator?
the correct connections. I mean,
So they have 2 different styles of threads, right?
Right for oxy, left for.
What else do they have? What's on the gas hoses? We just talked about it. Right.
The indication right there.
Right. So the red hose is a left-handed thread.
Yep.
The green hose is a right-handed thread.
Right.
So there's right and left-handed threads, on the regulators that attach to the cylinders,